So here we are discussing about the dielectric constant or relative relative permittivity. It is the measurement of solvent's polarity. So it means the solvent is polar or non-polar. If it is polar, so how much amount the polarity are present in that solvent. So water is polar in nature because it is having the H2O combination, the presence of hydrogen. They can easily accepting the aqueous media to miscible with each other. So here the best example of polar solvent is water. So we can measure the polarity of solvent by this dielectric constant. If the higher dielectric constant of solvent is indicating that the solvent is more polar. So water having the high dielectric constant, it means it is a polar in nature. It is the physical property. Dielectric constant, it means eta R, is the ratio of the permittivity of medium to the permittivity of free space. So here it is determined by eta R equals to eta upon eta 0, where eta R is the dielectric constant, eta is the permittivity, it means the permeability of the medium to the permittivity of the free space. Now this dielectric constant having no unit. This dielectric constant is affected by the attraction force between the atoms and between the molecules. So the solvent with the high dielectric constant make it possible to more effectively screen the attractive and repulsive force between the ion. So if any solvent having the high dielectric constant, so they are having more possible effectivity of repulsive and attractive force between the ions. So when the polar solvent having the partial charges, so that polar solvent act on the solute which having the effective charges. Now due to the effect of polar solvent, the solute decrease the attractive or repulsive force between the charged solute. So here the polar solvent having the ability to change the charge of solute. Now measurement of dielectric constant, so it is measured by effect of intervening solvent on the on the electric field between two opposite charged particles. So here the capacitances between the two plates for holding the test solution between the plates is measured. So here we put the test solution between the two plate, and that plate having some capacity to hold the sample. So this capacitance will be measured in this measurement of dielectric constant. Now after that test solution measurement, the measurement of capacitance is done by maintaining the vacuum between the plate. So very first two plate are placed, and in between that two plate we are putting the test solution and measure the capacitance of that plate. After that we remove the test solution and maintain the vacuum between the plates. Now this ratio is measured, so it means the dielectric constant is obtained, which is the ratio of capacitance of completely filled dielectric to the capacitance and capacitor filled with the vacuum. So eta equals to C upon C0, where C is the capacitance using the material. It means the test solution capacitance between the two plates. C0 is the capacitance using the vacuum. Eta 0 is the permittivity of free space. A is the area of two plate and T is the thickness of sample which is used here. Now what are the application of this dielectric constants? So they are majorly used to manufacture the capacitor, and this capacitor capacitor is used in many fields to store the energy between the plate to produce the noise signal for the resonant circuit, and so many. Second application is they are used in the electricity, and they are used to store the charges, and also they are used in the wires and cables. So this is the dielectric constant.